In this lesson, we're going to look at trigonometric graphs. Now that's graphs involving trigonometry, which is a topic we've studied before. In terms of graph work, we've seen straight lines, which are called linear functions. Linear means straight. Y equals mx plus c, y take b equals mx take a, and all that kind of thing. And we've also seen in the last topic quadratic functions, which are functions with an x squared in them that creates this parabolic shape. But now we're going to have a look at trigonometric functions and see how they arise. Now again, back to the idea of trigonometry. What does trigonometry mean? Well, if you break it up, tri means 3. We know that from triangles and triples and tridents. Gons is angles from polygons. And ometry is the study of measurement. Ometry. So we've got 3 angle measurements. Now we did a lot of triangle work to do with trigonometry in level 4, or 4th level, but that's not really where trigonometry ends. We did discuss that before. We did look at SOHCAHTOA, sine, cos and tan. It's expected you to already know this stuff. However, we're not really going to use it too much, but sine is the opposite side of a triangle divided by the hypotenuse. Cos is the adjacent side divided by hypotenuse, and tan is opposite divided by adjacent. But the reality is we're trying to talk about trig graphs. We're thinking, how do we turn triangle work into graph work? Well, again, in the trigonometry lesson that I taught you, we did talk about circles briefly and then moved into triangles. But anything that operates in cycles that's periodic and repeats itself over and over is thought of as trigonometric functions. So you can see here you've got triangles inside the circle, and the triangles can be created with different sizes as long as you're using a radius of the circle, and you create a down and across for a triangle. And you can also go this side, up and down and across, as long as the kind of hypotenuse is using a radius. Now again, we'll come back to that idea, but thinking about plotting values to make a graph, you could fire these numbers into your calculator. The sine of 1 gives you an answer, 0.175, the sine of 2, and so on, sine of 3, and you could all go all the way up to 89, and you pretty much get to 1. And you could also keep going after that, and if we're not talking about triangles, we're talking about this cyclic motion. We can keep going, go to 90, 91, 92, 93, and so on, and see what values pop out. And that's kind of what we're going to do. We're going to try and plot these. Now, to have a wee look at how this works. So imagine I've got a graph system plotting here, and I've got triangles over here. Now watch what happens if I take different values. So the sine of 1 is 0.02, pretty much. Sine of 0 is 0, so we're starting there. Now if I create a triangle here, sine of 7, sine of 8, sine of 9, sine of 10, sine of 11, lots of different values, they're all getting plotted here as we go. So that's the sine of 11, 0.19. Remember, sine is opposite side divided by hypotenuse, isn't it? We talked about that. Opposite side divided by hypotenuse. So I'm doing sine 20 at the moment, and I've plotted it, or this graph's plotted at 0.34. Just basically the values have been plotted from the last table I showed you. Again, we could go all the way up to sine. I think we went to sine 89. I think sine 89 was 0.999, something like that. It was something like this. That's it, nearly 1. Now, look at there, we're pretty much at 10.5 over 10.5 pretty much, and we're trying to work out, that's why you're getting 1. We're trying to work out what happens at the other side. So what happens over here is we start coming back down. What will happen is this number is going to get smaller, 10.1 in the top. We're now at sine 105, and we're at 0.97, so this is going to drop back down, you'll see it. So it's dropping back down if I take my triangles over this side. And then I'm down to here, 0 again, because my triangle's not really there. Now, when you take the triangle below, if you think of this as sort of like a coordinate grid, then we're going into negative values. So that's what you'll notice the red graph is going down negative. So we're going into negative values divided by 10.5, negative values divided by 10.5, until we get to negative 10.5 over 10.5, which gives you negative 1. And then what's going to happen is that number in the top is going to get smaller again. So we're going back all the way to 0. And you can keep going with this. And all that happens is that you recreate the graph. And you can go on and on and on. I don't need to stop at sine 360. I can go on and on and on and keep going and going and going. We wouldn't want to do that, but we could. What this is called here is a sine wave. Now the sine wave is a very interesting wave because the sine wave can be found in lots of different places, including music. Now music travels in waves, so does electricity, so does sound, so does light. Lots of things travel in waves, and we describe these mathematically with trigonometric ratios in sine, cos and tan, mainly sine and cos actually. So watch what happens here if I've had a real keyboard and I plugged it in to this thing's called an oscilloscope. You might have seen them in science. And if I play the notes, the sine wave's getting generated up here. Now you might notice the higher notes have got higher frequencies, which means there's more waves. Lower notes, lower frequencies, less waves. Now I plugged my guitar into an oscilloscope. I did the same thing. If you play the guitar, it pops up a wave on here in the oscilloscope. Okay, so there's a lot to take in there. But what we'll do is, if you take a heading of the sine wave, we'll try and recreate one in a kind of brief way. Now, what I mean by a brief way is, we're going to draw a table, and I'm not going to go sine of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That would take too long, so we're skipping every 30 to get all the way up to 360. The other thing we're not going to do is go past 360 because it just started to repeat itself and go round and round and round. So, if you draw this table into your notes, and then we'll have a go at drawing a sine wave. Okay, so if you're using your calculator obviously here, just type in sine 0. Make sure your calculator is in degrees mode. It should have a wee DEG at the top of a D. If you type in sine 0, you should get 0 underneath. So that'd be your first thing to plot. You could plot that, but we'll do that in a second. And then sine 30, if you type that into your calculator, it pops out to be 0.5. Sine 60, 0.866. And sine 90, that was 1. That's where it peaked. It started to come back down the other side at that point. So sine 120, 0.866. 150, 0.5, and the sine 180 back to 0. And that kind of gave us that kind of hill shape up like this and back down to here. But then, if you remember from the earlier bit, it went negative. So negative 0.5, negative 0.866, negative 1, and then it started to come back up to there. So if you fire these numbers into your calculator, you'll pop up with these answers. So what we're doing is we're plotting these numbers along the bottom, and then we're going up to 1 and negative 1 down the bottom here. Now in order to draw this in squared paper, what I tend to do is I use 3 boxes to get to 90, because I know I'm going to put 30 and 60 and 90, and then I know I'm going 90, 120 and so on. So I go 12 boxes altogether here, 3 for each section. Up and down here I'd probably use 3 boxes up to 1, 3 boxes down to -1. What you want to do, I'm not really going to do it here because I've got it. You want to plot your wee points, I suppose, here. And then for 30 you want to go up to a half, so round about there. 60 is quite hard to plot, but just guess it roughly, it's about there. 90 is quite easy, is 1. And you plot all your points, and you basically, what you end up with, if you join them all up, is a sine wave. Now, what we're trying not to do is trying not to make it too pointy. Don't go up like a triangle shape at the top. You're trying to make it curved. It should flow up, back down, and back up. Now all we're trying to do here is get you used to the sine wave and understanding how to plot it from just a table. That's all really we're trying to get you to do here. Now in terms of a quick way of doing it, you could just draw this kind of thing. This is what I was talking about before. 3 boxes, 3 boxes, 3 boxes. Now you can just plot your points. If you know where they are, you know, oh, that one goes 0. At 90 it was up to 1. At 180 it went down to there. At 270 down to -1. And there back up. That's a very quick way of doing it. It's a kind of fast way. We'll probably get onto that later. And then if you just try and curve your way up to there, curve your way back down, curve down to here, and then back up. Okay, so remember not to go too jaggy. It's not like a mountain. It's a curve. It's a wave. Okay, I would try the exercise in the lessons now in the book.